everyone. Welcome to today's session in graph theory. My name is Anjali Nigam, and as I've told you about myself before, I'm an assistant professor in engineering department. So moving on with our last topic, which was about the history of graphs, where we discussed how the Swiss mathematician Leonhard Euler gave the first theory based on the Königsberg bridge problem. Now, today's session is about basic terminologies in graph theory. These terminologies will be repeated over and over again in your entire syllabus. So please make sure that you understand them clearly. Let's get on with the presentation. The learning objective says that at the end of this session, you will be able to define graphs and its types. It states here that, first of all, we'll be defining what exactly is a graph, and then we will be moving on to its types. The definition of graph states that it is a pictorial representation of objects and the relationship between them. So what exactly is a graph? First of all, it is a pictorial representation. Pictorial representation means it is a visual representation. That is, it is represented through pictures or images. And what does it represent? It represents objects. I'm sure you must have read about objects in object-oriented programming, but to skip out any confusion, let's revise the definition. Objects are entities which have specific behaviors and attributes. So what exactly is an object? It can be any entity such as a chair or a car or a table or you or me. Anything can be an object, and objects usually have some specific behaviors, such as, let's take an example of a car. What is the horsepower of the car's engine? Or what is the color of the car? How many people can sit inside the car? Or if we are talking about a chair, what is the material of the chair? Or what is the color of the chair? So how these objects are represented? The objects are represented with the help of vertices. As you can see in the image, the numbers 1, 2, 3, and 4 are written in circles. These circles are objects which are represented through vertices. We call them vertices. You can also call them nodes. And the relationship between the objects are represented with the help of edges. You can see the arrows between different nodes, such as between 1 and 2, 2 and 4, 4 and 3, 3 and 1. Also, there are some arrows between 1 and 4, 3 and 2. So what are these arrows? These arrows are edges. They are used to establish relationship between different objects. So in this slide, we discussed about the definition of graph, that how it is a pictorial representation of objects and the relationship between them. Now moving on to different kinds of graphs. The first one is a simple graph. There is what is the definition of a simple graph? A graph without loops and with at most one edge between any two vertices. As you can see in the image provided for your consultation, you can see that there are no loops between any vertices. And you can also see that each vertex is connected to another vertex using only one edge. At most, there is only one edge and not more than one. So this is a simple graph. Now moving on to another kind of graph, multigraph. When two vertices are joined by more than one edge. So here you can see how the vertex number 1 and vertex number 3 are connected through two edges. First, you can see through a straight line, and another you can see through a loop. So in multigraph, two vertices can be connected by more than one edge as compared to a simple graph where the vertices were connected with at most, that is maximum, one edge. Now moving on to our next definition, it is about directed graph. When a direction is assigned to each edge, it is also known as digraph. So what does directed graph tells us? That there is a direction assigned to each edge. You can see that between vertex 1 and vertex 2, the edge has an arrow. It shows the direction. That is, 1 goes to 2 and not the other way round. So when a direction is assigned to the edges, it is known as directed graph. Directed graph is also known as digraph. The die has been taken from the word directed with di and graph, digraph. Moving on to our last definition, which is labeled graph. When each vertex is distinctly labeled, you can see in all the vertices that there is a number assigned to them. 2, 4, 6, 3, 5, 7. You can also assign letters to them, A, B, C, D, E, and so on. So when you label a vertex clearly, it says in the definition that when each vertex is distinctly labeled, that is, you're not supposed to repeat the names. If there is a vertex number 2, then no other vertex can be labeled as 2. And if there's a vertex number 3, then no other vertex can be labeled as 3, and so on. So when each vertex is distinctly labeled, it is known as labeled graph. So in this session, we have discussed graphs and its types. We discussed about the definition of graph, that how it is a pictorial representation of objects and the relationship between them. Then we discussed about simple graph, that how each vertex is connected to another vertex with at most one edge. Then we discussed about multigraph, where two vertices could have two edges between them. The third was directed graph, where a direction was assigned to each edge so that we can know the movement between the vertices. The last type of graph which we discussed was labeled graph. In labeled graph, we read that how each vertex was distinctly labeled. That is, the names cannot be repeated. If a node has been labeled as 1, then no other node can be labeled as 1. So students, I hope the topics we discussed today are clear to you. I would be seeing you in our next session, which would be about graph and its examples. In that session, I will discuss with you about how graphs helps us to solve our real life problems, such as in communications and networking. My name is Anjali Nigam. I'll see you next time. Thank you.